Now, way back in the day, nearly 140 years ago, when the automobile was first invented, there were no windscreens, there were no body panels, so climate control consisted of basically putting on a bigger coat. Nowadays, we get to live in these lovely cosseted bubbles. So of course, climate control is very important for the modern human, and most cars come with AC fitted as standard. But what is it? Well, we're here at Denso's Engineering Centre to find out. Now, when you open the bonnet of a modern car, you are greeted with a plethora of components, so it's quite hard to normally find the air conditioning components. Well, first up, if you have a look at the very front of the vehicle, you can see there's a sort of a radiator at the front. Well, actually, that's the condenser. That's like the radiator for the air conditioning. The actual car or the engine's radiator is normally nestling just behind that. Now, if you look on the engine itself, you can see things like the alternator. There'll be a belt driving that. If you follow that belt around, you'll usually find somewhere a clutch, another pulley, which is attached to the compressor. And that's really the heart of the air conditioning system. Now, off that will be a couple of pipes, and you can follow them around. You can see one, you can see here, has a little kind of connector on it with L on it. That's the low pressure connection valve, if you like. It's got a little Schrader valve inside. And then on the other side, if you look at the condenser, you can see there's another one that says H, and that's where your technician will actually connect his two pipes to the system, so you can either discharge or recharge the system using a machine rather like that one behind me. Now, you also see a little switch, or it's actually almost like a sensor on modern vehicles, and that's very, very important. That's what helps control the system. And if you follow the pipes all the way up into the bulkhead of the vehicle, inside, deep in the dashboard, the hardest part to change on an AC system is the evaporator and the expansion valve. And of course, they are also vital parts of this system. Now, it's obviously quite hard to see. Now, with the components out on a bench, it's a lot easier to see what is going on. But we'll start with actually the bit that's buried deep in the dashboard. So we've actually got our expansion valve here, but also we have the evaporator. Now, this is the bit that actually takes the heat out of your cabin. So if you imagine when the gas is expanding with the expansion valve, what happens is it obviously draws heat out of the atmosphere, and of course that's what the evaporator is doing. Now, that hot expanded gas then goes into the compressor. The compressor, as the name suggests, squishes it down and actually then makes that gas effectively even hotter. And of course that again has to go through into our condenser, where the fresh air flowing through the condenser reduces that heat out, cooling the gas back down again. It goes down through the switch to make sure everything's okay, or this little sensor here, and then it goes back around the system and then it expands again. So this cold gas, as it expands, it pulls more heat out of the cab, goes through the evaporator, and then so the system continues. So it is actually nearly simple. Now, the compressor really is the heart of the system, and I've got a friend from Denso called Richard who's going to help us explain a bit more about this. This is the modern compressor from our car, but of course you have a whole plethora in front of us. So can you explain a bit more about the origins of an AC compressor?
Yeah, we can start with that one, the fixed displacement compressor.
Okay.
So that means that the angle on the swash plate is a fixed angle. And while you rotate the compressor, it pushes 5 pistons from left to right on both sides of the swash plate.
Oh, I see, yes, so the pistons moving backwards and forwards.
You have suction on one side and compression on the other side. Yeah. Exactly. That one uses a magnetic clutch, so it switches on and off. So we have always, of course, maximum displacement.
Yes. Okay, so literally when this is spinning around, it's compressing gas.
Exactly.
Okay, hence why you have the magnetic clutch.
Yes.
Okay, so now this model, is that sort of based around the same era?
Somehow, yes. This is what we call a through vein compressor. You can compare it with a vacuum pump or power steering pump. It's the same principle. By changing the diameter of the inner cylinder, it sucks and compresses gas.
And again, it has a magnetic clutch because obviously when it's spinning, it's always compressing.
Yes, exactly.
Oh, that's interesting. Okay, so that suggests that this one, or our modern car, is slightly different. Is that right?
That's correct. This one is a so-called variable displacement compressor, and that means that the angle of the swash plate can vary between minimum and maximum displacement.
Oh, I see. Okay, so this could be spinning and actually not doing any compressing at all.
Exactly.
But then as soon as this plate here is actually moved to maximum, if I spin it and you find a little space.
Yeah. So by moving, then you can move like this, you know, change the angle of the swash plate, and therefore you change the displacement.
So yes, it's completely variable. So the idea being that you actually then have a fixed pulley rather than a magnetic pulley.
Exactly.
Because obviously it can be modulated electronically.
Yes, it's continuously driven.
Oh, that's really interesting. Okay, so that's quite interesting. So then, of course, so we have our magnetic sort of clutch here. So you have a big electromagnet that actually then pulls the clutch to kind of jams them together, just like in a car's gearbox. And of course, that then means that you've actually got the pulley spinning. Is that right?
Exactly.
Fantastic. So then the difference then with these ones is they've actually got sort of like almost like a fixed, in fact, you see all the little rubber bits falling out. So there's like a dampered.
Yeah, we call that
joint.
a DL pulley, damper limiter pulley.
Okay.
So for the variable displacement compressor, we use mainly a damper limiter pulley, so compressor is continuously driven.
Yep.
And it has a safety mechanism inside. So when something happens with the compressor, let's say
jams
oil
up for whatever
jams
reason.
up
Yep.
because of no oil, then the limiter will break and the pulley can run free.
Right, fantastic. Yeah, so it doesn't actually
Doesn't
break all the other belts or anything.
Exactly.
You just end up with no air conditioning, but everything else on the car is
Power
still running
steering,
fine. So
battery
you're not
charge.
actually going to crash and die. Brilliant. That's a very, very handy thing. Wonderful. So then you actually come on to the last two compressors here. So what's different about this one?
This compressor is a so-called scroll compressor. It has a fixed scroll and a rotating scroll. And it's different compared with the piston-type compressors because it doesn't have a suction valve or discharge valves. So it's depending on the flow of the system.
So it has a kind of a constant in and a constant out.
Yeah.
And so essentially, I guess it's a little bit like if you imagine a cone and it's kind of taking a gulp of air, and of course as the air moves or the refrigerant moves along the cone, it gets smaller and smaller and smaller and smaller and compressed to the very end, but that's been wrapped around a shaft, so it's constantly compressing air constantly all the time.
Exactly.
Right, okay, fantastic. But then that one has a magnetic clutch, so you can turn it on and off again
yes.
as well.
Yes.
Okay, fantastic. And then I suppose now, because cars are going electric, obviously got electric drive all over the place, so we now need to have an electric compressor, because you can't rely on a spinning shaft off an engine.
No.
And that's what this chap here does, is that
Yes.
right?
So it's the same principle as the mechanical driven scroll compressor, but then this one is driven by electric motor.
Brilliant. No, that's fantastic. So, okay, so we now get how all of these are spinning around, but of course to keep them spinning, we need to lubricate them.
Yes. So let's start with the ND Oil 8, which is a PAG 46 oil, basically used for the piston type compressors, but also for the scroll compressor.
Okay.
Then we have ND Oil 11, which is a POE oil, which is used for the electric driven compressor because it's
As an insulator.
exactly.
So basically, yes, yeah, because you don't really want obviously sparks flying, quite literally.
Because the electromotor is cooled by the mix of refrigerant and oil.
Right, clever, okay.
Then the ND Oil 9, which is a PAG 100 oil. The higher the number, the thicker the oil.
Okay.
And that is exclusively for the through vane compressor.
Right.
Then we have ND Oil 12, which is also PAG 46, but then especially for the new type refrigerant R1334YF.
Right, yes, so because there are different refrigerants over the years,
Yes.
and of course just trying to make it basically better for the environment as we go.
Yes.
So the thing is then, there is no such thing as a universal oil, is
No,
there?
no.
Right, so it's very important that you know, A, what the gas, of course, is in the system, but
Right.
therefore also what the mechanism is and therefore what the oil is.
Which type of oil?
And
to be
presumably most of the compressors, or certainly the manufacturers, are going to specify what compressor oil to use.
used. Yeah, every Denso compressor has a label on it to identify the type of compressor, and there's also mentioned the type of oil which is used for this compressor.
Cool. Okay, so we've now got some working compressors. They're now compressing our refrigerant.
Yeah.
So once you've got some compressed refrigerant, because obviously it takes energy effectively to do the compression, you're going to generate heat. So you take the heat out of the system. So then we need to talk about condensers. Okay.
Exactly. Let's do that.
So condensers. We have a nice big stack of condensers. Now, obviously, this is the serpentine condenser. Is that right?
That's right.
And that's because it looks a bit like a serpent or a snake. You can see it starts at one end and goes all the way around back to the other.
Yeah.
But there are variations of this as well.
Yeah, we had the single flow serpentine, and then the dual flow, and the last one was the triple flow serpentine type condenser.
Okay, so then what would happen, instead of just going one in, one out, it would go kind of one in, but then it would split to two or to three branches.
Yes.
Then go around and then come back into the one.
Exactly.
Okay, and then before this, like in ice cream vans and that kind of stuff, you'd have actually had like a round copper pipe rather than the flat one,
Yeah.
which is even more inefficient.
Right.
Right, okay. So we're starting to move. So now this one, you can see, is more like a conventional car radiator,
Yes.
so that the elements are actually effectively in parallel.
Parallel flow, or we call it multi-flow
Right.
type condenser.
Okay,
Yeah.
and that's because, yes, so basically it will go in so on one side and kind of go across
Yeah.
and then come out the other side.
And it's more efficient it also reduces the amount of refrigerant.
Oh, right, okay, that's interesting. And then it's lighter, and
Yep.
it's thinner as well, so
Yes.
of course it just saves more space in the engine bay.
Exactly.
Okay, fantastic. And now obviously to go with this, you'd actually also need a dryer.
Yeah.
And then so that's one of these little cans here. So that'll be, well, it could be kept almost anywhere actually on the vehicle itself, obviously in the engine bay somewhere, and effectively the refrigerant's going in one end and coming back out the other.
Yes.
And inside here is kind of like a material, a bit like the silica gel you'd have in a sort of a little package or something, wouldn't it? Just to try and take the moisture out of the gas.
Yes, but today we call it zeolite.
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 Okay. Sounds very expensive. Excellent. That's fantastic. So now, get rid of that one as well. So we're moving on from there. We now come to something which is much more modern.
Yes.
So this is still a parallel
Flow or multi-flow type condenser, but then this one we call a subcool condenser because it has an additional heat exchanger in the lower part of the condenser.
Okay, so there's cool, which is what those are. This is subcool, so below that. So it's actually lowering the temperature.
Lowering the temperature of the refrigerant, exactly.
Okay, so it works better in hotter countries, or it's just more efficient?
It's more efficient because we want to have, let's say, the lowest possible temperature of the liquid refrigerant.
Yep, okay.
And with the subcool condenser we can achieve that.
That's fantastic. And this then essentially is the dryer again. This is just like on our car here,
Yeah.
but it's actually called a modulator.
Yes.
And that's because it's modulating what?
Between, let's say, the gaseous part, gaseous liquid part, and the liquid part flowing through the subcool part.
Right, so as our hot gas comes in from the compressor, comes into here, and then it actually gets turned into cold liquid.
Exactly.
And that's the modulation.
Yes.
Right, that makes perfect sense. And actually, it's quite nice. We've got a little cutaway here, so you can see inside, you can see all these little balls of zeolite, and that's what's removing. So they're just kind of hygroscopic.
Yes.
So they like water.
And they catch the moisture inside.
Yeah. And then, so why is moisture bad in an AC system?
It creates acids inside the system, which can, of course, cause corrosion inside the system.
Okay, and is there anything to do with the fact that also, I suppose, it has a different sort of chemical cycle? Is that, so it's going to expand into steam and all that kind of stuff differently, or is that not really a problem? It's just the corrosion.
There's a risk of freezing up the expansion valve.
Right.
If there's too much moisture inside, then the expansion valve can be freeze up because then we have low temperature there.
Okay, so whenever you service a system, you really should change this.
When you open up a system, you always have to replace the filter inside.
Yeah.
Yeah.
Okay, fantastic. Right then, so now, if we just remove that, we now have what I guess is the most modern version of all of these.
Exactly. This is what we call the GIC condenser. It's the Global Inner Fin condenser.
Okay.
And it's the latest technology of Denso. You can see the difference. This was, let's say, the previous one.
Yep. So
and this is the GIC
So that,
condenser.
to me, I mean, it's probably very difficult for the camera to see that, but you can see. So this, the original one is like an aluminium extrusion.
Yes.
Very tiny.
Yes.
But so effectively, it's like lots of little straws all stuck together. Yeah. Now, with this new version, it looks kind of the same, but it looks like it's got more folds. Perhaps.
Yeah, it's an assembly of folding aluminium. While, as you said, this one is made by extrusion.
Yeah.
So this is an assembly of, let's say, two different types of aluminium.
Right, so then it's all kind of folded like a big lot of origami,
Yeah.
almost like corrugated cardboard, I suppose. It's all sort of stuck together.
Yeah.
And then is it welded to seal it?
Yes, exactly.
And then you've then got to weld that to the cans on the sides?
Yes. So
that sounds hard.
It's magic.
It's magic. That's fantastic. And so this would be the same sort of thing that's actually in between the elements. And again, this is all about trying to get the cool air to exchange the heat that's actually inside the radiator.
Yeah. So to absorb as much heat as possible, Denso uses louvers inside the fins.
Oh, yes.
So that means the air is forced to take a longer path when it's flowing through the
condenser. So it literally kind of scrubs off as much heat as possible.
Exactly.
That's really, really clever. And you can see, there is quite a... So that's a Denso invention, in fact.
Yes.
Yeah, awesome. Very, very clever.
Just like this one.
Now, we haven't really spoken about plumbing. So when you think about it, you've got a condenser, you've got some sort of warm-ish liquid fluid, if you like, liquid refrigerant, is going to get piped through a pipe from that condenser to the expansion valve, then it goes through the evaporator, and there'll be another pipe coming out from there going to the compressor. But this is quite a clever little innovation. So this is actually combining both pipes, isn't it?
Yeah, correct. We call this an internal heat exchanger.
Okay.
So it exchanges heat. It takes liquid from two pipes. So liquid outside the outside tube and the gaseous refrigerant in the inner tube.
Okay, yes, so you've got like the high pressure, sort of quite warm, like 45 odd degrees of the actual refrigerant in the outside. That goes in like almost like a liquid jacket around the colder gas, the sort of low pressure that's kind of just flowing through the other way. So it just makes the whole system more efficient. And actually it's also one thing less to sort of route through the engine.
Yeah. But it has also the length has to be restricted because otherwise your superheat gas will be too hot.
Right.
So and then compressor lubrication becomes critical because if the gas is too hot, then there's not enough oil return to compressor.
Okay, but Denso worries about that.
Yes,
That's
exactly.
fine, okay. So we've got our cooled liquid going through the system. It now has to go back up in through the interior of the car, and then we have basically our evaporator. But this is an older version of an evaporator.
older version.
So what's, I guess it's just thicker,
Yeah.
looking at that.
So this was, say, the first aluminium type evaporator. We call it the slim evaporator.
So they were thicker than that once upon a time. Yeah, okay, right.
But you can make it from, these are all sections, and it's very easy to create bigger or small. Yeah, exactly.
Yes. Okay, that's clever.
So after this one, we see more and more the multi-flow. It's based on multi-flow technology.
Yep.
It's called the super slim evaporator. And so it's more efficient than, let's say, the previous one.
And of course, again, because it's physically smaller, it's got more room in the cab for every other bit of the car.
Yep.
And also it's lighter, again.
Lighter,
and all of that's going to add up over time. So effectively, if you compare an old AC system back in the day to one now, it's probably going to be like half the weight, I imagine, with all the...
And also half the amount of refrigerant used.
Right. Okay, that's also very
inside the system.
important. Yeah, okay, that's very, very neat.
Yeah.
So now, of course, then we've saved the best to last, really. Obviously, you've got your little switch we talked about slightly earlier on. Now, this, back in the day, was a switch, but now it is also actually a sensor. And in fact, it does definitely more than one job, doesn't it?
Yeah. So when we talk about the sensor, it creates a linear signal between 0 and 5 volts.
Okay.
And that controls the compressor, but also the cooling fans.
Right, okay.
Yeah, so switching on and off cooling fans, but also switch on and off compressor.
And is there also a fail-safe in here? So if the fluid or the refrigerant leaks?
Yeah, when the pressure is too low, then of course the system is not operating.
Right, okay, so this has actually got quite an important role, even though it's quite small and insignificant. Yes, okay. Now, did you change that, regularly, or is it something that you just basically, once it fails, you then change?
Normally, it doesn't need replacement.
Fine, fantastic. And then, of course, the really important bit, now this is two different versions of the same thing. These are the expansion valves, right?
Yes.
So you're going to have one of these just before the evaporator. So normally that would sort of sit, I guess, up here somewhere. Yep. And the idea is, of course, this is the bit, the magic bit. This is the bit that basically takes your warm away from your interior. So what happens is, as the name suggests, the fluid, if you like, the refrigerant that's in liquid form, goes into one side of the valve. When it comes out the other side, it actually is allowed to expand. Yes. And that goes into a mist, is that right? And then that mist obviously eventually turns into a gas. But it's obviously effectively evaporating inside the evaporator, hence the name. Yeah. So that's obviously quite sensible. And then probably the best way to explain that involves a little bit of excitement. Now, air conditioning systems rely on a very simple physics principle, the ideal gas law. Now, if you have a fixed volume of gas or refrigerant, in the case of our air conditioning system, there are three factors that kind of work on that, but they need equilibrium. So you have temperature, volume, and pressure. And they all need to be kind of equaling out. So if you use our compressor, in the case of the AC system, it actually squishes that volume into a tiny space, and that conversely lifts the pressure and the temperature right up. But then, when you pop it through the expansion valve, for example, you then let that volume get bigger and bigger and bigger, and therefore, to keep equilibrium, you end up with the pressure and the temperature dropping. So that is exactly what is going on with our expansion valve, hence the clever name. Now, obviously, there are a number of ways we could demonstrate that, but perhaps the most interesting, or at least exciting, is with one of these, a fire extinguisher. All right, here we go. Now, as you can see, the moisture in the air is now collecting on our little pipe here because so much of that lovely heat has gone away and it's now nice and cold. That's exactly how our evaporator works.